Okay, so I'm going to start off with looking at this problem number 11. Now it says that n is the incenter. So what we know about the incenter is that it is equidistant from the legs of the triangle. So if ND is 6x minus 2, and whoa, I'm sorry about that, and NE is 3x plus 7, then these two pieces have to be equal to each other, and we would know what the length of x is. So we could just set these two equal to each other. So if we do that, so we have 6x minus 2 equals 3x plus 7, and we can solve that out. So 3x from both sides gives us 3x minus 2 equals 7. Add 2, so 3x equals 9, so x is 3. And then it says find the length of NF. So we don't know what NF is, but if we just substitute 3 into either one of these two expressions, we can figure out that NF, 3 times 3 is 9, plus 7 is 16. Okay, so then same kind of idea here. So you have NG and NH. So that's the same kind of problem. We don't have to really do anything with that one. And it looks like, okay, so then we have a circumcenter problem. I just found this online, so. Okay, so P is the circumcenter. Use the information to find P to Z. So we want this. Okay, so what we know about the circumcenter is that it's made up of perpendicular bisectors and it's equidistant from the vertices. So if P to X, use a different color here. So PX is 3x plus 2. And PY is 4x minus 8. And since P is the circumcenter, then this point is equidistant from all the vertices. So that means that these two expressions have to equal each other. So 4x minus 8 equals 3x plus 2. So subtract 3x, so that's x minus 8 equals 2 plus 8, so x equals 10. So then to find PZ, we can substitute 10 into either of these and figure out that the length of PZ is 32. Okay, so if it was talking about, say, the length of AX compared to AY, we know that since this is the circumcenter and these are perpendicular bisectors, that these two have to be equal. These two have to be equal because remember they're bisectors, so these are congruent. These are congruent. For the incenter, there wasn't really any rules with that because they were angle bisectors. So there's not really much we could do with that one. But then we have a centroid. Okay, so we have this point G is the centroid. So the centroid is the balancing point, and if you use the chart, it says that it's made up of the medians, so that's when you cut your sides in half, so all of these are congruent. And then point G is 2/3 the distance from the vertex to the side. So from G to C is 2/3, G to D is 1/3. So point G So B to G is 6. So that's 2/3, and then GF is 1/3. So that means that each piece is 3 because 6, no. Yeah, because 3 and 3 gives you 6, 3 more would give us 9. So GF is 3. Let's see, AF is 12, so then F to C is 12. A to E is 15. Okay, so if AE is 15, 15 is the whole thing. So we're going to divide that by 3. So A to G is 2 pieces of 5, so that's 10. And G to E is 1/3, which is 5. So this is 5 and this is 10, so that's 2/3 of 15 and then 1/3 of 15. Oh, I'm like not really showing you my work, I'm sorry. Okay. So FC is 12, we got that. A to G we found is 10. B to F. So B to F is 6, so that was 2/3, and then our 1/3, which was 3, so that gives us a length of 9. And then we found out that G to E is 5. All right, well, I hope this helps. I hope this gives you some clarity. Let me know if you need any further explanation on anything. Sorry for me bumping into my camera holder here, or I should say my phone holder that I'm using as like a camera holder. But yeah, let me know if you need any help.